A warm welcome to the third and the final demo session for MATLAB. So in the last two demo sessions, we were introducing the MATLAB interface. We dealt with how to write a code or an M file within MATLAB. In this tutorial, we are going to see how to use the Simulink tool of MATLAB. So let us go into the Start button of MATLAB, which gives you access to Simulink. So in Simulink, the first option is Library Browser, which helps you to see what all are present within the library of Simulink. So unlike writing an M file, the Simulink part of MATLAB offers you to write code by using block diagrams. So in this, we will consider two examples, one from signal processing and the other from communication block set, and explain the basic blocks involved here. So if you take the signal processing block set, we see the following blocks. There is a sine wave. So if we add this sine wave to the new model by right clicking, you will open a new model file and the particular block of sine wave is inserted here. Now if you double click on this, you will get the properties of this block. So this sine wave has amplitude 1, so let's make that amplitude as 5, which means the peak to peak voltage or amplitude is 10 volts. Now the frequency is set as 100 and we have put it in the discrete mode. Output is real and computation method is trigonometric function, which we will not bother for the time being, and let us say that the output should catch up with the simulation time. So there is only change that I have made in this block set that makes the source. Now let's try for the sinks that are present within this block set. So we go into this block set again and look for signal processing sinks, and we see a time scope. So we add that time scope also here and connect this block to the time scope. Now we shall also add a spectrum scope, which will measure the frequency of the sine wave. So we have input the frequency of the sine wave to be 100. Let's verify whether that would be correct. So let's see the properties of this time scope. So when you double click on the time scope, it just opens the FFT block. So the FFT blocks computes the FFT by using the window method. So that means it computes the FFT using a finite length. So let us run this by giving the runtime to a large value, say 1000, and by clicking on the play button over here, the simulation gets started, and we get the spectroscope output should to be showing two peaks of 5 magnitude at 100 and -100, so which verifies that the frequency response is correct. Now if I take the time signal over here, I can see that the time signal starts with a delay and it is expanding up to the 1000 mark. Now secondly, we take the example of a communication scheme. So this is the binary pulse shift key, or the BPSK as commonly known. So here we have a baseband communication scheme where the input pulse is a Bernoulli random variable which is fed into a BPSK modulator and then passed over the AWGN channel, which is a noisy Gaussian channel. Now let us see what is the output of this model. So if you analyze this, the BPSK symbols are either +1 or -1. Now while it is passed through the channel, noise or the random noise is added to that BPSK. That is the reason why the actual symbol gets scattered and you get the scatter plot to be varying with time. This is a real-time experience that we get from MATLAB. So as time progresses, the symbols are randomly being projected along the x and the y axis. See what is there in this block diagram. So the Bernoulli source generates random variables 1 or 0. So it is a pulse of width say 1 second and having amplitude as either 1 or 0 with equal probability. Now the BPSK converts these 1 or 0, which are known as bits, into symbols plus or minus 1. So it has two phases, a 0 degree and a 180 degree phase. That is the reason why it's called as a binary phase shift key. Then the phase shifted signal is modulated using a sign. So if a plus 1 is to be modulated, I apply a positive amplitude sine wave. If minus 1 is to be transmitted, I apply a negative amplitude sine wave and it is passed over the AWGN channel and the output is observed as a scatter plot. Now we'll demonstrate one more experiment. So this is a video image processing experiment that is available in the demonstration within MATLAB. So let us run this and we'll explain as we run this. So what this experiment does is it is going to count the number of vehicles that are on the road. The input to this experiment is through a camera mounted on the road. So we need to identify whether a moving object within this frame is a vehicle or not and give the number. When there are no vehicles, we get the background image or the road. So once it is saved, it will be remaining forever. Now once the background is available, you can subtract the background from the original video and we'll get the background subtracted moving image part. So in this you will get only moving objects or non-stationary objects in the video. Once we get that, we need to identify a rectangular box around this white pixels, and that is what is being done in this fourth plot here. So this is a real-time system again that uses the concept of background subtraction to do a video image processing. So we'll discuss more about this as we move along the course. That concludes our final demo session. Thank you for your patient listening.